We're back.
We are.
All right, welcome back. We're going to have our groups report out. We've got a couple of our groups trying to get online so they can share some of the interesting things that happened. Let's start with the online group. What did you, what are the contexts did you use?
So we were kind of talking about, and you can see I hit my free limit, but we were talking about how, students would stop. I think it was Marianne in the quad and ask her about doing conversions, and so and for nursing students, and so we asked, and I think I'm sharing my screen.
Yes, you are.
Can you explain how to convert milliliters to centigrams for nursing students? Ask clarifying questions along the way. And so it asked a couple clarifying questions. And so we said we wanted a straight formula, and we also want a scenario where this would be seen, and gave it the answers. So it gave us the straight formula, the volume times the concentration, times 1/10. And then it even said if you want centigrams directly from milliliters and milligrams per milliliter, this is the simplest formula. Then it gave us an example scenario where a patient's prescribed amoxicillin and has ordered 10 milliliters. So it even worked it out for us, gave us the 25 centigrams of amoxicillin, also gave us a quick reference formula for the nursing students, and then it offered to do an infographic. And there's where our infographic still sits at this point, which is probably because I've hit the limit.
That's what prompted Brad a little while ago, being on to ask for some big graphic or something. I think it exploded.
We didn't know whether it was because we added the graphic piece or were we asking it to do too much printing? So that's something you need to experiment with.
Mm-hmm. For sure.
That's it.
So yeah, I was gonna say, yeah, that's it in a nutshell.
Thanks so much, Robert, for doing all the typing.
Yeah, happy to.
Any questions for the group? Vessel?
The case for this particular example, but at my university, we had an AI summit to kick off the year, and we had a student panel, and there were 2 nursing students and they specifically talked about with nursing and dosage problems using a typical ChatGPT OpenAI. It will give you problems, but it actually will give you wrong answers. And it wasn't until they started using Notebook LM, where their professor has linked their textbook, their nursing textbook, as the source, then they started getting correct problems, correct formulas, correct answers to quiz themselves for their tests. So I do think it's important that students are careful and that they are aware that depending on what source it's pulling from, and it's going to pretend like it knows the correct answer. So in that people's lives,
That's the hallucination.
I certainly want my nurses using the one where it's connected.
Critical consumers of information is a pretty important thing to do. Are using an AI or not?
Yeah, but I think that's become a big general education issue that didn't exist, the information literacy.
Yeah. Well, we always had the National Enquirer, so it always was something you can go to get bad information. Okay, any other questions for our online group? Thank you. Thank you. All right, can we have one of our groups here? Columbus?
Oh, yes.
They need to share a screen.
Yeah, they can share. Anyone can share.
I just use through your audio then instead of trying mine.
Yeah.
Yeah. I mean,
They went a slightly different direction. I probably didn't get around to everybody here, so on them in particular to share.
Okay. So we asked the question that we were a high school teacher and we needed a lesson plan for, like, we wanted a week worth of lessons introducing this injection molding process. And we were told that was excellent. So we were very excited about it. Yeah. So it came up with the lesson theme and the central problem. And then it gave us a day-by-day breakdown of your objective, your activity, your focus, and some, we had asked for DOK questions. So the first day it gave us DOK 1, and then it moved along to DOK 2, as it learned more, as the students were learning. And so, it gave us the activities and things like that to do. So when it would give us everything, then we would ask it another question to involve more into it. So then we asked it like, well, how do these days align to the Ohio Learning Standards Command? And then it came up and told us exactly for each day what standards we're going to be. Yeah, and then.
Were they the right ones?
You're right. Well, that I don't know.
Nobody knows it.
But if your principal comes in.
$7.2, not 7.3.
I really liked how it had the standard, the concept of standard, and that what the focus was for the real world.
That's good.
And then just some logical notes for it. And then we went on and we asked it like to rewrite this, but include the learning intentions and success criteria for each day. Absolutely, this is a great next step. We are great reminders.
Chat GPT loves you.
And then we're like, okay, well, this is great for core instruction, but we need something for small group, right? So like I've done my core lesson, but now I need an activity for a small group. And then I go down further here.
One's parenthetically workplace realistic.
But was really neat when it gave us the small group, it also told us different roles the students would have, right? And it changed it out there. Handouts. These are the handouts of trackers. Yeah. Yeah, it gives a lot of stuff. And then the student projects portion, it created a peer rubric so that they could grade each other.
So did you guys really like it?
Well, I like how you could build onto it and it remembered better than I did what it had just given me. Yeah, so here's small groups. So day 1, activities called mapping the machine. They each get a laminated diagram of an injection molding machine, and they have to identify these different parts of the process, and then identify where the map is used in them. Gives you the purpose, material you're going to need, things like that. And then, like Leilani mentioned, it also gave us a rubric that the kids would use in different roles, like how to structure your time.
But as we were saying, and when we encourage, when that comes up in our professional development days and teachers are asking, well, I can just put my standards or whatever in Chat GPT and it makes lesson plans. Well, it does, but you are ultimately the final editor of those plans because it's your responsibility to make sure that what has been given to you actually meets the objective it's supposed to meet. And the mathematics is that's great. Yes, it's a wonderful time saver if it's actually accurate. Otherwise, you're just rewriting all of this again. But it can be wonderful, but getting our people to realize that, yes, this is great, but you've still got to do the work to get in there and make sure that it is what it says it is. And the rest of that. So this looks fantastic, but
And I think it makes it even harder because it's formatted professionally.
Yeah.
It has the illusion of being professional.
Yes.
If you're on a textbook review committee and somebody hands you an entire textbook, how do you choose between textbook A, B, and C, that's fine. It's a huge job to try to make, well, this one, is formatted really nice and has ancillaries, but to get down to knowing what the content is a huge chore.
Like it walks you through this injection molding, which I assume is correct, but then I don't know if like on day one, am I using a deeper part of that algebra standard than I'm using on day two? And then what part of that algebra standard is covered in the
Yeah, and the thing is, when you get into teaching for in context, that doesn't matter as much as you have been led to believe your entire life. People don't learn linearly. It's like all math standards is like, you can't teach the quadratic formula before you teach factoring. The earth will stop spinning, but it really doesn't matter. I mean, if you do things in context, the students are going to learn the skills to do what they need to do because they're interested in the context. So it's, teaching quantitative reasoning, trying to get college faculty to let loose of like, you don't have to teach every single probability rule and get them to be, 3 weeks of backfill before you can give them a medical testing problem. It's really just using understanding of percentages. When you're taking percentages of percentages, which blows their mind and things like that. But it's not, they don't have to be probability experts to do an application of probability. So that's, I think, it's gonna, so there's two things going on today. There's the AI aspect and there's real world applications. Most math teachers totally freak out in real world applications. And then the AI is a whole nother layer. Because if you're going to teach this stuff, you really should know something about batteries or welding or whatever it is.
Real world applications, the numbers are not needed. That's one of the reasons we have the phone problem. So the numbers are needed. So how does this work out here? Are these numbers needed or do they go off like a real problem?
I might have a calculator for the not neat numbers. And that's the real world. And if we teach only neat problems, then we go to the real world and say, wait a minute, these numbers aren't neat. I can't do it.
And it's not only that they're not neat, they're not certain.
Does this particular program come up with neat numbers or not neat numbers? And do we know that? And is that important to them? Because we don't want all these numbers. And I mean, I haven't done the problems, but it looks like they were coming, when it works the problem for you, it looks like they were getting good neat numbers.
Yeah, I agree.
So that's because I agree with you.
Another thing, facet of that is, so you focus on high quality instructional materials. So it comes back to the teacher to be the arbitrator of that in the classroom.
Yes.
And it's the same thing. I mean, all you were talking about, it looks really pretty. But there are lots of instructional materials, people selling really pretty garbage.
Well, and then the idea that for our say, well, then that's treated as a script. That's not your script. That's not what you're exacting from. That is to get your brain to inspire the idea, to get you to think in that direction. That isn't your teaching script for that day, that week, whatever that is, and getting them to understand that, while again, yes, it's a wonderful tool to help spark your creativity and see the possibilities. That doesn't mean cut and paste it onto the Google Doc, print, staple it together and submit it in lesson plan. That's not at all what that is. I mean, it's wonderful, but the chances that in any scenario, you'd be able to use all of this?
No, what?
Can I just say the problem is more
What?
how the classic problem, you know, the classic problem.
Yes, I've seen him.
How to come up with
New classic problems?
So,
problems with dark.
Okay, along this line, okay, and believe me, I sincerely apologize for the fact that I have to ask this question, okay, and you'll know why I'm saying that in a moment. Okay, so as long as I can remember, the pocket calculator has existed. Okay, so I realized.
Oh, yeah, you are.
And I just had a milestone birthday last month, so yeah, okay. So, but I'm genuinely curious, and again, I sincerely apologize that I have to ask this question. I'm genuinely curious, for those who might remember when pocket calculators were not so common, how did people, you're right, yes, yes. How did people come to be convinced that, for instance, the square root function, you know, gave us the correct square root? Yes. And I have the sense that I know part of the answer to that or whatever, but I'm curious for those who may have experienced that in a more.
I mean, in the calculator, how were we convinced the calculator was giving us the right answer? It matched up with the tables in the back of the book.
Yeah. Okay.
No, that-
Okay, yeah.
When you did the long division style.
Yeah.
And you're assuming that everybody's,
I did want to-
you know, you're assuming everybody's content.
Well, yeah.
Now you remember, now, again, way before your time, you used to be able to hit the third button, hit the square button, and it didn't come back to what it was before, because they chopped it off at a certain point.
Yeah, okay, right.
But yeah, if you do multiply the number by itself.
Well, that's fair. Okay, all right. Yeah,
Why is
that
it
makes
a
sense.
nice number?
Much bigger question, that there are all these mathematical tools to use. But in the statistics world, if we're using SAS or SPSS or R, how do you know that those functions are not? In fact, there was a time, I don't know if they fixed it, where Excel did not yield the right answers on some things, so at least with the accuracy that people want.
But I remember checking the calculator against the truth table.
Oh, yeah. No, I did. The trig in particular. Yeah.
I guess my just ongoing question, which relates more directly to what we're doing here, is so if I did want to verify, you know, all these things, like let's say, you know, let's say I didn't know anything about the 5-day lesson that you all came up with, and I wanted to verify all of that. Wow, how would I go about doing it? I mean, again, it's going back to the time of how do I evaluate this? Yeah.
Well, one of the things I would suggest that everybody consider is you start looking into these authentic applications out in the business industry sector, is develop a relationship with some of those folks that are subject matter experts there. I'm not an expert at what Paul and I just looked into, and I've got questions I want to ask some of those folks. You can't be an expert at everything. So if you're going to do real stuff and you want it to be, you know, authentic, legitimate, etc., you need to have those conversations with folks in those areas, which is a rare thing in some settings.
And maybe that's something we need to be advocating even more for broadly, which I know a lot of us believe in anyway. Yeah.
We familiar with, for all practical purposes.
Yes.
This was the coalition for math and its applications out of.
Co-math, all of our home.
Yeah.
They actually worked with
Yes.
people who knew.
I have
The
Saul
real
on speed dial. Not kidding.
What's that?
I have Saul on speed dial. No kidding.
Yeah.
He likes to fish food. So.
Yeah, for those not online and looking at the chat, and added that any and all use of AI, especially by teachers and students, must include reminders, info about ethical use, and cautions about accuracy, etc.
Yeah.
Within the lesson plan /tool /scenario, etc. Maybe a statement that was generated by AI and has or has not been reviewed for accuracy and appropriateness for use in the classroom, etc. Says that at the bottom, you notice when you're looking at your screen at the bottom, so Chat GPT can make mistakes. Check important info. That's not. And then Jen also added, wondering if Odoo has a phrase that teachers can use on lessons, like Jen say. That kind of stuff.
We need more lawyers involved. Yes, thank you. Paul, should we share out here?
Okay,
Paul and I goofed around a little bit while you're pulling that up. We were looking at the Intel stuff and I knew a teeny tiny amount. Paul knows lots more about the manufacturer of semiconductor stuff. And the first thing they have to have is silicon wafers to build these chips on. And those silicon wafers are cut out of big, long silicon crystals that they call ingot. And we wanted to know a little bit about producing those ingots that they saw into the wafers that you see getting turned into chips down the road. You want to share out, Paul?
so our question up top there is what scenario where technicians are growing silicon for semiconductor production? Came out with a wonderful thing of, so essentially to grow a crystal, you have molten silicon down the bottom. You put a seed crystal in it, you spin it, and then you pull it out, and the crystal grows as you pull it out. So you have the variable temperature of the silicon, how fast you're pulling it out. And it didn't talk about, right, rotation probably, that's something to do with it too, but, so they gave us this table of pull rate of some samples over 10-15 minutes of what, they're shooting, they want to have 200 millimeter diameter is what we told. So they give us all this information, gives us some issues to address, looking at cause and effect and that kind of stuff. Gives us basic algebra equations for kind of figuring this out. So then we started asking some questions. Well, can you give us a graph of the diameter versus power? And so it took the table, we just took those two slices of the earlier table and graphed it. Now I'm thinking, well, we've got two variables going on here, not just one. So we essentially did the same thing with this, and it gave us an equation for that. It said we'll do the same thing, but with the other variable, and you get that, but then again, you get about two different things, so how that would help you. So part of it's doing it. So now can you give us a graph of diameter versus power and pull rate? And so it gave us the table again. But then it gave us a graph, but then it worked everything out. So you get this equation, quadratic equation here that sort of solves that particular problem. And then it came up with some nice questions, so if you're doing that, well, basically how you can use this. So now we know if the diameter gets too small, we can increase the power, or we can slowly rate it when we're pulling it out. Or if it's too big, we can do the opposite of that, right? And so then some discussion questions. So if you're down to 190, you're trying to stay within 0.5% or something. You're down to 198 at this rate, what do you have to do with the power? And so now you know, go into that graph and that equation what to do. And this was looking at it probably a little bit differently, more, okay, we've got this problem, how do we go about solving this problem? And there are wrong ways that didn't really get the answer, there's a right way to go.
So for a neophyte growing silicon ingots, I learned lots in 15 minutes of fussing around there.
Yeah, like way
I'm
back.
not sure if it's fantasy or not, but it sounds like it's
So there's the CZ just run speed method.
yeah, the
Process.
formula problem. The same. Thank you.
Now you'll know what to do.
You're here. You guys were doing
Drugs.
Yeah.
Been pulling this.
the same custom.
Yeah.
Let me go back a few times.
There you go.
We got, no, that's way at the front, I'm sorry. It's back to another.
But while she finds that, I wanted to say, like, particularly our Columbus groups, they showed that, the answer to Janet, the other group's question, none of us got kicked out because we didn't ask for an image. And we have really long sets of hits.
Yes.
So I'm wondering if David really does have something turned off there for uploading images.
Images, yeah. Really, they were asking them generative.
Mhm.
ChatGPT is starting to, but it's still.
Sort of makes sense.
Not really.
Pretty,
It's all large language model.
yeah, well, that's not as pixelated.
Acid graphs, which I don't see a lot anymore.
I think this is,
Yeah.
okay. We started with, so what's the engine?
That we wanted to know what they do because we wanted to see if the scenario does reflect like a realistic situation that they do. So we learned here and we chose to do, I think we asked first about the bone, like bone disease, the scenario about bone disease. This is when we went down. And then it gave us really an elaborate, like, even though we didn't ask about the mathematics involved with what the engine does, it gave us like what are the mathematical skills that they would need. Then that's the problem. Then we asked them to give a scenario, like what would a technician do if they were working on the development of drugs to treat bone disease. And the reason why we asked that also because of my background is science, so I was interested in whether they would go into like nature of scientific experimentation. But it wasn't, that wasn't very clear about the actual, doing of experiments, what does it. So they gave us an example and a formula about cells, and they mentioned they were genetically modified cells that have to be integrated, and they don't know. And this was what the problem is. They have to figure out how much time should they leave them there, because if they leave them too long, then they could actually deplete the nutrients and the backfires on them. So that was more background information. And this was the example of the classroom exercise. So we wanted also a quiz about like giving value statements about the genetically modified, and we asked them to give us like what type of questioning. And they had some good questions. They were a bit like too general, but still they had some good questioning about. And they one thing we liked was that they also did like clarifying questions, probing assumptions. So there were like the questions were also categorized. Then we had a tip to add another scenario, which is, we also tried to do like diagram and image, and it was not.
Oh, that's a great picture.
Yeah, where to go, like where to go. Yeah, this was the image. These are the references of paper. And then we have a more specific one, which is create the scenario for students for a bioreactor hold. It was inspired by the map about, and then again, we got another problem in the issues and what could so here also they had like what are some misunderstandings that students could have, what challenges when they try to solve this problem, like conclusion exponential growth with just multiplying by 2. So we were more like adding prompts. Here's another scenario based on technicians.
And we had lots of
so this one was when we put data in, the good thing was that it actually did give us some, I think it gave us like the patient and then some data about the patient.
The 55-year-old, there's a 55-year-old compared to a 30-year-old.
Yeah.
So in the fast scroll through there, I just see gobs of good stuff, I think. I mean, I saw some statistical references up there. I saw icky numbers in scientific notation. I saw GUI units of all variations.
GUI units.
Yeah, I mean, that's not your average textbook problem.
No, no.
Customize, I mean, the interactive aspect of being able to customize as what you want and take it into direction, that's not always available with traffic tools.
Theoretical versus measured values. Ooh.
So there is definitely for the education and versus interactive affordance that.
And I think that ethical process, if the person being produced threatens the who's they like it and how might find I like the ethical question.
And you could prompt it now, you know, are there other ethical issues with
Yeah.
something, and it might produce.
No, this is clearly medical. Did ethical problems come up in the more traditional manufacturing?
No.
There were no ethical problems involved. But no, I
Maybe because we also did the something like remember like the genetically modified, like this was a value. So it's like a value heavy question.
Okay.
It was you know, like, so it also probably maybe takes the hints of what we might be interested in and start getting, you know.
So we have asked questions and we're more. So maybe.
Well, I think that the bio has a easier in than, I mean, we were looking at welding and geometry. I don't know that the ethics is gonna pop up there quite as easily.
Yeah.
We didn't get very far. We asked, what are some math problems that are related to electrical vehicle battery protection? Because we really had no idea what they would be. So came up with this mixing active material slurry, which turned out to be some interesting math problems, not difficult, but interesting one. And said that a 200 kilogram batch would require certain percentages of things. And two questions were asked: how many kilograms of each component are needed, and you know the density of what will it occupy. So we went back where it says at the top scenario, it's a mixture of active materials like lithium, nickel, manganese, cobalt, oxide, carbon black iron, and solvent. And it took us a while to figure out that 200 kilogram batch mentions nothing about the solvent and what it takes up. So we had to look that up. And there are a bunch of other problems because we didn't get to, okay, and they, you know, they looked interesting, but we didn't get to them. So we had to ask a great technical question, which we asked, what's the typical mass percentage? And it gave
Great
yeah,
great
great technical question. And that was a great question. I can't take any credit. So I just typed. So we first did 50-50, but that was interesting. Then we did a 60-40, which was a little more interesting. But it really made a difference because normally somebody would say, well, if it's 200 kilograms of the solvent of the stuff of your compound, then 94% or whatever it was is going to be this. Well, it wasn't because the solvent's taking up so much. And so it turns out it really could be half of that. So these are percentages. Yeah. So, and then it says solvent typically takes up 30 to 55% of the slurry mass on this. And then it also tells you what are the problems if you don't have the right stuff. If it's too runny, too solid, too whatever, it doesn't conduct, it's too much of them, you know. So a lot, like you said, I learned a lot in 15 minutes that I didn't want to. But it made my appreciation of the math problem that, like, I do have to care about this because I drive an electric vehicle and I'd like the guy who's making it make sure I'm getting, you know, the goodness. So.
And then goes back to your ethical question and the the latest phone every year. Where do these things come from that are making these? They're all, like, where, like, what country has been taking them the most to make these things that make our phone?
And where are we getting lithium from, where we get?
And the story, it's a little surprising, when I was in chemistry class, we didn't make up any solution for, we had 40% solvent and 60% of stuff that was being dissolved in the solvent. So this is a big group. I mean, that's what I call this slurry. It's not like you're putting a little bit of salt in your water and stirring it up in your mouth with salt.
Yeah, we could afford to get back 60% salt, it'd be like, wow. Right now, and that battery, we can verify your hypothesis. But then I need a lot. Might start a fire.
Right, and then another thing, we had to make some assumptions, like when it said carbon additive, we like, well, we're gonna assume that carbon additive is carbon black. So there's kind of switched terms from the stem of the question to where the quoted is given. And so anyway, I think that's a reasonable assumption, but with any kind of real world stuff, you almost always are making assumptions, and you need to get your students in the habit of stating the assumptions that they're making instead of just saying, oh, that must be it and going on.
Thank you.
Yeah.
Leslie and I looked at the welding and cutting. I can't remember the name of the company now, but we looked at it in context of geometry because they're cutting things out, and there was a lot of talk about the angles without giving any specifics, and a lot of the placement of bolts, again, without getting specifics. The one application that was very good was the talking about the placement of the shapes on a sheet to be cut out to minimize waste. So that was an interesting application, and it included the math of the interior angles and the exterior angles, talking about using regular shapes, and hexagons and octagons, I guess, are typical shapes that are used. And so it did talk about that. It didn't, like,
We had to modify to get to that point, so
Yeah.
it only pretty much gave us rectangles, triangles.
and circles, yeah.
So Michael's like, we need to up, because I kept saying like, is this really high school geometry? So that's when Michael was like, let's add trapezoid, regular polygon.
Yeah.
And then it got a little better.
Kind of had to tease it out though.
Correct.
Yeah, it took a couple, but and there's a lot of, for this, there would have been a lot of ancillary materials you would have had to find. Talking about welding diagrams and a couple of other things there that you needed to go out and get. And it also has on the screen is this nice regular hexagon area formula that frankly I had never seen before. It's correct, I checked it.
The general formula is 1/2 the applicant times the perimeter.
Yeah, that's not,
Just
yeah.
specialize it to.
Or that's another
Yes, and that's where this one came from, and I remember when I remembered the equilateral triangle formula, I said, "Oh, okay," but this isn't one that's taught. I mean, like Greg says, it's half times perimeter, but it's not that's not a normal formula. But I guess if you're making hexagons, it would pop up. So it was interesting. There was still a lot more questions, I think, that we needed to get answered, but And it was a 3-day lesson consistently. So it was interesting. I learned some, and there's a new formula.
I did see mention of the curve from there, which you were.
Yeah,
What?
and that I thought of you. Like,
Yeah, and that was,
Did you
which I
tell it,
didn't know that the waste had a name, but
did you tell it to do 3 days, Michael?
no.
Yes, yeah, I did.
Oh, no, we told it to, yeah.
Okay, thank you.
And we, after doing it from a, like, okay, now you're a geometry teacher. And pulling some welding concepts, then we were like, okay, now you're teaching welding students. And we wanted to see how it changed. It kept the 3-day structure and it kept like the topic or like the big idea of the day 1, day 2, day 3. The same, but slightly changed it a little bit.
Yeah, because in every iteration, day 3 was about conserving material.
Which could be a very big deal.
Oh, no, I'm sure it is. I mean,
If and for ethical reasons.
Yeah.
So,
ethics is everywhere. All right.
I'm trying to get for saving materials instead of use things that test it like.
Yeah, but you have to be slightly bigger. Yeah. Yeah.
Then allow for the will.
Yeah.
Yes.
Ross?
Yes, now that you've all played and seen and shared and stuff like that, the next thing we wanted to do was something that was very popular, they're playing mostly on Greg there, is the gallery walk relating to some issues involving this AI stuff. So in your groups that you've been working with here, we'd like you to take a little time to respond to those 5 things that we'll put up there, and I will stick the giant Post-it notes on the wall with headings associated with each of those 5 things, and ask you to cycle around and provide some response to those. Since you're now all experts at using AI generative. So.
They'll be up in a minute.
They will.
Take a deep breath.
I'll take care of that while you all start taking care of those things. You've vented about some already, so it should be,